Welcome back to ASAP Physics. Today, in this video, we will be covering the unit reflection and mirrors. To start with, what is reflection? Well, reflection is basically where a light wave, or any type of wave, comes in contact with a surface and bounces off in a different direction. Before we move on, let's quickly discuss what real and virtual images are. For our purposes, when an object is reflected from a mirror, and the image appears to be inside of the mirror, then we say that the image is a virtual image. However, if the reflected image seems to be in front of the mirror or on the screen of the mirror, then we say that the image is a real image. So now let's look into some examples of these virtual and real images. As you can see here, when a person looks through a plain mirror, he can see an image of himself inside the mirror. We consider this image to be a virtual image as the image appears to be inside the mirror. Now if we come to our attention here, the real image, on the other hand, the image comes outside of the object. So as you can see here, when the object reflects off the mirror, the final image appears to be outside of the mirror, therefore we consider it to be a real image. Before we move deeply into reflection, let's take a brief moment to look at all the types of mirrors that we would be covering in this unit. The first one is the plane mirror. The second one is a concave mirror. The third one is a convex mirror. To make sure you get your concave and convex mirrors right, a concave mirror bends in like a cave, while the convex mirror bulges out. The plane mirror, on the other hand, is just a flat mirror with a plane surface. Let's begin with plane mirrors, as it is the simplest to deal with. Imagine standing in front of a plane mirror. What will you see? You would see an image of yourself on the other side of the mirror. When the resulting image appears to be inside the mirror, we refer to it as a virtual image. All plane mirrors produce a virtual image. Moving on, let's look into an example that you would see in any test. The problem would be like, find the direction of the reflected ray. In order to do that, let's look at this example. As you can see here, we have a light source of a bulb that is producing a light wave towards a plane mirror that is horizontal to the surface. Now let's figure out how to figure out the reflected ray. First, I would start off by drawing a line of normal. The line of normal is always 90 degrees to the surface. Now, I would measure the angle between the actual ray and the normal. Let's say for this instance that the angle is 50 degrees. After finding the measure of this angle, I would then add this angle to the other side of the normal. Now, the final step in order to find the reflected ray is to connect the point of contact to the angle, and that would be my line of reflection. Always remember to add the arrow head to make sure that the reflected rays goes forever. Now let's analyze the diagram we have just made. The angle between the actual incoming ray and the line of normal is known as the angle of incidence. Now the new angle we have found and added to the other side of the normal is known as the angle of reflection. And finally, the line we have just made is known as the line of reflection. Now with the knowledge we have learned, let's try to apply this knowledge into an extensive problem. So as you can see here, the problem here is asking for us to find the final image of this object. Now, automatically, we should know that since this is a plane mirror, it is exactly just going to reflect onto the other side with the same length and width and the same distance away from the mirror. But let's just use our ray diagram skills and figure out where the image of the object is going to be. Now, to start off, we would first make our rays. This is the first incoming ray coming into this side of the mirror, and this is the second incoming ray that is coming onto this side of the mirror. Now, after we make our line of normal and our line of reflections, we should probably get our line of reflection something like this. Finally, just to since I don't have space on the whiteboard, I'm going to kind of make this a little more modified, but finally, in order to find the image of this object, we would extend back from the reflected rays and figure out the intersecting point. Let's say the intersecting point is right here for now. Well, this is where the image of the object is going to be. So now key reminders here is that the lines that come behind the line of reflection are always going to be dotted lines. They would never be solid lines. Now finally, to end off the video, I want to cover a few more concepts. So in a plane mirror, when an object is reflecting off, the image would appear as a virtual image. Now let's talk about some characteristics about the virtual image. The virtual image would have the same height as the initial object. The virtual image will also be the same distance away from the mirror as the object, but in the opposite direction. As you can see, this concludes the plane mirrors. And that is all for plane mirrors. See the following video on concave and convex mirrors.